uh, another important practical, that is the 17th practical. Write down the topic, determination of, now listen carefully, right? This practical is somewhat complicated compared to this one. Write down determination of the angle of refraction, determination of the angle of refraction angle of deviation, right? Determination of the angle of deviation of a prism, angle of deviation of a prism by observing the variation of deviation, caused by a prism, Okay. Okay. So here we are going to use optical pins as well, right? Around the prism we are placing optical pins. So these are another set of practicals, very important, right? Oftentimes they ask this in the exam. Okay. So here, this is what we are going to do. We are going to get a bunch of incident angles. Let's say simple I. So depending on those incident angles, we can get the angle of deviation, not the minimum deviation. Angle of deviation, you can find this. Then at the second part of the experiment, we are going to find the prism angle, right? Since we know the angle of deviations at each cases, then you can find the minimum angle of deviation, which is d min. So once you know d min, by substituting this in this equation, by substituting those values in this equation, you can find the refractive index of prism material. So this is what we are going to do in this experiment, right? So for a bunch of different values of I, you are going to find angle of deviation on the prism. Then you can find the prism angle. Then by substituting those here, you can find the refractive index. So that is what we are going to do in the experiment, right? Right. So in the lab, let's say this is a drawing board or something, or this could be the table, right? Surface of the table. Then you place a white paper then you clip that to the board. On this board, you place the prism like this. So basically, this is what we are doing. So from above, you are looking at the prism, right? Prism and the optical pins are around this. So basically, this is about the practical, right? Just take this down. Take this down. Right. So these are the stuff that you are going to draw on that white paper, right? So let's say this is the paper. So you get the paper, right? So the first step, you need to draw a line like this. Using a meter rule or something, you can draw this line. Let's say AB line. So what are we going to do here? We are going to mark. We are going to actually draw bunch of incident angles. So to here you draw the, let's say this angle. Let's say this is 20 degrees. This is 20 degrees. Then here you draw 30 degrees. You draw the normal, then draw 45 degrees. You just keep drawing these, right? About for 6 incident angles, you do the same thing, right? But here I'll explain how to do it for just a one. But as you are doing the experiment, you have to do this 6 times for different incident angles, right? Okay, I'll just explain how to do it for a one. So first you draw the normal, right? Normal. Then let's say the incident angle is this much. Let's say that is simple eye. Then what do? You have the prism, then you place the prism like this. One side on AB line, you place the prism. One side here. So to this side, this is the incident angle, right? Then what do? So this is the how you would see that. So you have the prism here, here. So on this line, you place 2 optical pins. Here you place 2 optical pins on this line. Then place the prism, right? So the optical pins are here. You look from this side, right? From this side. So what do you see? You see image of this, let's say P1 and P2. So you see 2 images from this side, like this. This is the image of P1, image of P2. That is what you see when you are doing the experiment, right? You place 2 pins here. So you are looking at these 2 pins, but you cannot see these pins, right? What you see is, when you look through this prism, images of these 2, like that, in 2 different places, right? Let's say this one P, this one Q, and this one R, right? Just draw these 2. First, just take this down. Thumbs up, right? Once you've taken it down. One is P1, another one P2. So these are images of P1, P2 from QR side. So here the goal is, you need to find, so you know that this is incident here, this ray incident here, is incident here, then emerges from this side. So what you have to find is the path of this emerging ray. So that is the goal here, right? Okay, listen carefully actually what happens here. So I'll just draw this again. Right? So you have placed, let's say P1 here. Let's say P1. Then P2 here. Right? you know that from P1, light rays goes to everywhere, right? To all the directions, light waves spread from P1. But we only need light rays incident on the prism. So these light rays are incident on the prism like this. There are many light rays like this being incident on the prism from P1. Then from P2 as well, light rays are incident on the prism. Light rays goes to the other sides as well, but we only need light rays being incident on the prism only, right? Right. Then you look from this side, right? You look from this side. You know that there's a light ray that goes onto P2 as well. But that light ray is obstructed by P2 pin. P2 pin, right? After that, that won't reach here. Then what happens? So if you think about this light ray, right? This light ray, from P2 as well, there's a light ray coming like this. But if you think about this light ray, image of P1 is covered by P2. Here what happens is it is incident like, it refracts like this and emerges like this. Then you can see that. So what do we need here? There are many light rays coming from this side, right? But you have to move your eye so the P1, you will not see the P1. You will see that these, let's say this is image of P1, this is image of P2. So as you are moving your eye, this P2 will cover, image of P2 will cover image of P1. So you will only see, at a certain point, you will only see one image, not two images. That is the case, then we can say these two are in a one line, right? So from this you can see that. So this one is blocked by P2. This is blocked by P2. Okay, take this down and thumbs up. If you don't understand something, let me know. Right. Then what do? Once you identify that line, then you place other optical pins, let's say P3 and P4. You place these two optical pins, right? Okay. So you keep moving the eye, till you see only one pin, only the one image of the, because other pin is covered by the P2, right? Then along that line you place two pins, right, like this. So what do you have once you taken those? Then once you place these P3 and P4 pins, everything is complete now, right? For a one incident angle, you have taken the necessary measurements. Then what do? You remove the prism. Right? Then what do you have? So you have this line. On the white paper, you have this AB line. You have already drawn this This line as well, you have drawn that. Let's say P1, P2. You have drawn that, right? After that, what you have is positions of these two pins. You have two punches here, right? You remove the pins as well. You have two punches here, like that. Let's say like this. These are the positions of P3 and P4. P3 and P4. So the initially light ray is going to go along this path, right? It was going to go like this. But because of the prism, it has deviated. Here. So that that path is found, then you draw a line along these P3 and P4 as well. Then you can draw this line and this line, right? This is the incident ray. It was going to go like this. But finally, as it emerges, that ray emerges from the prism, it has deviated this much. So this is simple d. This is the angle of deviation. Angle of deviation. If you draw it here, you can extend this one. Then this is the angle of deviation. Simple d. Then the prism angle is here, right? Do you understand? So everything is happening at this vertex. At this vertex. So the prism angle is here. So this is the angle of deviation. So using a protractor, you can measure angle of deviation. You already know the angle of incident angle, you know angle. Then using a protractor, you can simply measure simple d. So that's what you do. So this is for a one incident angle, right? You have to do this for at least 6 incidence angles. From like 30, 40, 45, right? You have to repeat this same procedure. Okay, draw this one as well. Right. So this is just for a one incident angle, right? So you have to do this at least 6 times. Then those readings, you can record them on a table. Let's say you got like these readings 30, 40. Just take this down with me. 50, 55, 60 and 70. Let's say you take this and you have about 6 or 7 values, angles of deviations, right? Now what do we do? Using D and I, we can draw a graph between incident angle and angle of deviation. So angle of deviation is the y, right? Incident angle is what we change. So this I is x, this d should be y. So to the y-axis, we put angle of deviation, incident angle to this one. Then you have to mark these coordinates, xy coordinates on the graph. So you will get marks like this. I mean coordinates like this. 1, 2, 3, 4, something like this, right? Then using a flexible ruler. You need a flexible ruler to place here, right? You cannot use just a meter ruler. You need a flexible ruler to place on this. Then you can draw a smooth line like this. Not a line, I mean a smooth curve like this. So once you draw the curve, you can find the minimum angle of deviation. This is where the lowest point, right? Minimum angle, we call that D min, or we call that D, capital D. So at the minimum angle, you know that for a prism, I1 and I2 is equal and R1 and R2 also equal. In theory, you have learned that, right? Right? Take down this one and draw the graph. So that is how we find the minimum angle. Okay, so this is how we find the D mean, right? D mean. Okay. Then write a subtopic, find in prism angle. Find in prism angle within brackets capital A. Find in prism angle within brackets capital A. So here in the diagram, you have to clearly see where the prism angle is, right? Remember the diagram? It was here, right? This angle is the prism angle. According to the side we took, right? Prism angle is at the Q vertex. So here we are going to find the prism angle. So to find the prism angle, you have to identify the Q side of the, Q vertex. Then what do? You place the prism like this. Q vertex is here. And these are P and R. So what you do is, you place the prism like this. Then you draw a line like this, right? Then place P1 and P2. P1 and P2. So what happens? Part of this ray refracts into the frame. And there's a partial reflection as well. From this side, there's a partial reflection, right? So that when that happens, this I and this I is same. By using the method I explained earlier, you place P3 and P4 pins, right? P3 and P4 pins. Again, then you have another line. You can use the same pins, but I'll say P5 and P6. Then that gets partially reflected from this side as well. Then you place P7 and P8, right? Then you can take the prism out. Then you can do necessary drawings. So the drawing we are going to do is, you have to extend this line here, extend this line. If the prism angle is capital A, it is here, right? In theory, you have learned that if it is A, this angle should be 2A, right? If the prism angle is A, this angle should be 2A, right? Okay, take this down. These are two parallel lines, right? These two are parallel lines. Just draw this one. Thumbs up once you draw that. So these surfaces should be polished, right, for this experiment, because these surfaces has to act like mirrors, right? You are using image of reflection, not refraction. Reflection. Earlier you used refraction, right? So like about 80% gets refracted, 20% gets reflected, right? About. So these surfaces should be polished, well polished. So you have different prisms when you are doing this experiment, but we are using the same prism. So you have to make sure that it is polished. Polished means you can using a cloth, you can polish that, right? Both sides. Okay, take it down and thumbs up. So this surface, both surfaces, those are polished, right? Polished surfaces. Right? Okay, so now we found minimum deviation angle, D mean you found, and the prism angle also you found that, right? So if you need to find the refractive index, you can simply substitute those values here. In this equation, prism angle you know, angle of minimum deviation you know. You can substitute those and find the refractive index. Okay, write down below, write down by substituting D by substituting capital D found at first part and capital A found at second part in the equation below, refractive index of prism material, can be found. Refractive index of prism material can be found. Refractive index of prism material can be found. Then write this equation. So I can simply substitute A and D values, right, in order to find a refractive index. You have to remember this equation, right? Sometimes they give just a 1 mark just for remembering this, right? If you remember this, you can get a 1 mark. Right. Then the special points I have to discuss. First, just take this down. Point 1, write down, when fixing optical pins vertically, they should be placed when fixing optical pins vertically. They should be placed at a considerable gap. So a unique line can be gained. A unique line can be gained to represent the light ray. Okay. So now listen, right? You know that you place these optical pins. So when you are placing them, you are not going to place them like this, right? Very close. You are not going to fix them like very close to each other. You have to make them apart as much as possible, right? So you will have a very unique line, right, which will represent that ray. So they ask this in the exam, right? Okay, then the second point, take down second point. If QR, if QR side, if QR side is marked, if QR side is marked at the first part of experiment, at the first part of experiment, comma, after finding the intersecting point, after finding the intersecting point of P3, P4, after finding intersecting point P3, P4, and QR, comma, by drawing a normal, by drawing a normal angle of emergence, angle of emergence can be found, can be found. Okay, to the same line, right? The same angle of deviation, the same angle of deviation is available, is available for this emergent angle as well, for this emergent angle as well. Full stop. So we can increase, so we can increase the number of coordinates, number of coordinates when drawing the graph, when drawing the graph. Right? So this is no, Q is here, right? So this is the prism. Then there's the incident angle like this, right? I. We have already measured the incident angle, but we didn't measure the angle of refraction, right? Because we didn't draw this QR. We only needed simple D, right? We only needed the angle of deviation. So we didn't draw this one earlier. But in this sentence, what they explain is, if you draw this QR line, if you draw this QR side, what can you do? So you know this that you know these two locations, then you can draw this line, draw this line. If you have drawn QR as well, what can you do is you have this one, then draw a normal to here. Once you draw the normal, you can find this angle. Angle between emergence ray and the normal is I2, right? Then you can use in a protractor, you can find I2. Right? Then by this method, you can increase the number of coordinates. It is more coordinates, more xy coordinates, the better you can draw the graph, right? Let's say it is something like for I, for an incident angle 30 degrees, let's say you got 43 of angle of deviation. For an incident angle of 30 here, you got angle of deviation 43. So in that case, so this is 30. In that case, let's say this I2 is like 58. So for 58 as well, you have the same angle of deviation, 43. Right? Now you have an extra coordinate from one. So you do the experiment once for a one incident angle, you have two coordinates. Why is this? You remember that reversibility of light? So if you send the light from here, it goes like this. If you send the light from this side, then this angle becomes the incident angle. And that also, this light ray also would move along the same path. It doesn't matter which direction you send the light ray, right? It will have the same path. If they have the same path, they will have the same angle of deviation, right? So for I1 and I2, we'll have the same angle of deviation. So just by doing that, this experiment one time, you can take two coordinates, right? For 30, if it is 43, and if you measure this angle as 58, for an example, right? 58. For 58 as well, without measuring, you can just directly put 43. That is what we call reversibility of light. I'm not going to explain theory parts, right? Those are theories. So for the same angle, incident and emergent angles, we would have the same, not the same, I mean two different incident angles, we can get the same deviation. So you can like double the number of coordinates. So if you have more coordinates, it's better for the graph, right? When you're drawing the graph, it is easier and better and more accurate. Okay, don't draw this one. You don't have to draw this. We have earlier drawn this. Just take this table only. Take the table only down. I think you understood that one, right? You have two incident angles for the same deviation. It is the reversibility of light, right?